Hi class, today's lesson is from Illustrative Mathematics, which is our text. We're in Unit 5 on solid geometry, and this is Lesson 14, Working with Pyramids. And the objectives for today, by the end of the class, you should be able to say, I can calculate the volumes of pyramids and cones. What is more, I can work backwards, given the volume, to find the possible dimensions of a pyramid or a cone, maybe the radius or the height or the area of the base. So the first part of this lesson is to take, here we have a pyramid, and it's got some dimensions on it. And the question is, which, if either of these two, has the same volume as the pyramid? Is it A? Is it B? Is it both, or is it neither? And to do this, you will need to solve for the answer. I'm going to do that now on my whiteboard. I suggest you pause this video and try to do it first before you watch me do it. So here I have the pyramid. The volume of a pyramid is equal to, let me write this down, the volume of a pyramid is equal to 1/3 the area, is equal to 1/3 the volume of the base, the area of the base, times its height. So this would be 1/3 times, this is the length times the width, 5 times 4, times the height, which is 6. This is going to be an answer of 40. This is a rectangular prism. The volume is equal to the area of the base times the height, which is length times width times height, which is 5 times 4 times 2, which is 40. And here we have a right triangular prism. The pyramid. This is a 1/3 times the area of the base times the height. Now, what kind of a base is this? The base is a triangle. It is a right triangle. It's got a right angle. This would be 4, this would be 6. So this would be half of the rectangle. So it's going to be 1/2 of the length times the width. So this would be equal to 1/3 times my area of my base is 1/2 times 4 times 6 times the height of this pyramid, which is 10. And my answer is 40. Why, sure enough, they all have the same volume. Amazing. When we go on to the next thing, pyramid practice. The purpose of this part of the activity is to practice solving problems involving pyramids and cones. And you may use a scientific calculator. To calculate the volume, I would suggest you write the formula, substitute the values, and solve. Round your answer to the nearest tenth, or if it does not have a decimal, just leave it to the nearest unit. I need to see your work. So on each of these, there's a problem page, and then there's a page where you can actually upload your work if you choose not to type it in or to write on the drawing here. So you can write on the drawing or you can type it in. And there are several questions here. There's 1, 2, 3, 4 questions, I think it is. And I'm going to show you how to do these at this time. So if you want to pause this and try to do it on your own and then check your answers with mine, you can. So the first question, here is a pyramid. It looks like a square pyramid. And so the volume of a pyramid is equal to 1/3 times the area of the base times the height. My base is going to be a square, so it's going to be 2 times 2. And my height is 6. So if I do 1/3 of 6 is 2. And 2 times 2 times 2 is 8. And this is going to be in feet. So my answer is going to be in feet cubed, because it's got a length component, a width component, and a height component. Next we have, looks like an oblique cone. A cone has a volume of 1/3 the area of the base times the height. The area of the base is a circle, so that'd be 1/3 times pi times the radius squared, which is 2 squared, times the height, which is 4.2. And if I plug this into a calculator, which I will do, I'm going to have to call up my calculator, Desmos Scientific Calculator, and I'm going to do waiting. 1/3 times 4.2 times 2 squared give me 5.6 And then I have to multiply that times pi. So I'm just going to leave it in terms of pi, 5.6 pi. This would be approximately, so if I plug in pi times, and I'll use the term pi, which is going to give me more exact, 17.6. It's approximately 17.6. And this would be, the units would be centimeters cubed. I put the units in brackets. I suggest you do that. And you could also circle your answer, which I didn't do on the previous page, but I should. Here we have a triangular prism, and a triangular pyramid. So the volume is equal to 1/3 the area of the base times the height. The base is going to be, this is my base, it will have a 3 and a 4. It's going to be 1/2 of that area, is the area of this triangle. So this would be equal to 1/3 times 1/2 times 3 times 4 times the height, which is 7. My answer would be 14, and the answer is in kilometers cubed. Man, what is we talking about here? At the size of a planet, a small asteroid or something? That's pretty big. Cubic kilometers is big. And finally, we have this figure. This, again, is a pyramid. Volumes of pyramids is equal to 1/3 times the area of the base times the height. We're told that the area of the base of this is equal to 32, and the height is equal to 12. So when we multiply, let's see, 3 goes into 12 4 times, so 4 times this would be, what, 128, and the units is in centimeters, so this would be centimeters cubed. I'll put my units in brackets and circle my answer. Questions? Comments? Did this match up with what you got? So we can show our answers on each of these. Let me see here. Let's see, where are we? Practice with pyramids. A particular cone has a radius of r and an h of h, a height of h. Write an expression for the volume of this cone in terms of r and h. And second, what is the height of a cone whose volume is 16 pi cubic units and whose radius is 3 units? So let's do that. I'm going to so the volume of a cone, waiting. Don't know why it's taking so long. If I have the volume of a cone would go to 1/3 the area of the base times the height. Now if this cone has a radius of r and a height of h, my volume would be 1/3 times pi times r squared times h. We are told in this description that we have a height of, the volume is 16 pi and the radius is 3. So if my volume is 16 pi, I'll substitute the values. This is my formula. I'll substitute the values and then I'll solve. 16 pi and a radius of 3, so I have 1/3 pi times 3 squared times the height, which is what I'm looking for. What is the height of this going to be? I'm looking for this variable. So I'll do the inverse operation. First of all, 1/3 times 3 is going to be 3. So I have 16 pi is equal to 3 pi times h. Now I'm going to divide both sides by 3 pi in order to get this h by itself. So I divide this by 3 pi, and I end up with 16/3 is going to equal to, and that's going to be in units, will be my height. That's my answer. Oh, let's see, there's a second part to this question. I didn't see this. It says here, what is the radius of a cone whose volume is 16 cubic units, 16 pi cubic units, and whose height is 3? So let's substitute that number into this same equation. So I'm going to use this same equation, and I will substitute the values in. 16 pi is equal to 1/3 times pi times the radius squared times the height of 3. Well, this could be simplified. 16 pi is equal to pi times r squared. If I divide both sides by pi, I get r is equal to 6, r squared is equal to 16, so r is equal to 4. Here I am using the formula to solve for something other than the volume. So if I'm given the volume, I can use the formula by substituting and solving. And this graphic organizer, formula substitute solve, will work for a bunch of what you do in high school, at the high school level. Here we have one in particular. Let's see, did we just do this one? I don't know. Yeah, just did this question. So this next one, the pyramid in Gaza. I don't know if you can see this or not. It is 455 feet tall. The base is a square of 756 per side. How many Olympic-sized swimming pool volumes of water can fit inside the pyramid of Giza? We're told that it's, I'm going to draw the picture here, and I will show you how you can draw a picture of a pyramid. We'll draw part of the base like this. I'm going to draw the other part with dotted lines. I'm going to extend this further over this way, and like this. Now when I bring it up, I bring this one with the dotted line because it's in the background. And you can see that this, each side is 756, and my height, I'm told, is 455 feet. It is one of my bucket list items to go see the pyramids. I have 2 of my children have already seen it. I've never seen it. This is 455 feet. Each one of these is in feet. So what is the volume of this? Well, the volume of this would be 1/3 times the area of the base times the height. That's 1/3 times 756 times 756 times 455. So the volume of the pyramid is, let's just plug this into our calculator, 756 times 756 times 455 times 1/3 times 1/3. 866282960. 8 is equal to 86682,960. My units is in feet cubed, or cubic feet. Now we know, maybe you don't know, an Olympic-sized swimming pool, if you Google it, it'll give it to you in cubic meters or liters or something weird. I want it in cubic feet because I want to know how many pools, X, how many pools is this going to be? X pools per 86682,960 is equal to 1 pool for how many cubic feet is it? And if you Google it, it'll tell you 88,000 cubic feet. This is, the units here is going to be in pools per cubic foot. So I'm looking for X. If I multiply both sides or divide that by 88,000, so if I take this number and I divide it by 8800, well, I'll do it times 1/88,000. I end up with, what? 985.0. This is approximately 985, still, it's almost 1,000, Olympic-sized swimming pools. And water only weighs 8.33 pounds per cubic foot, so it's like, what? Or pounds per, is it pounds per gallon? Pounds per, anyway, that's a lot of weight because it's all rock. And that's huge. Anyway, I would love to see it. The pyramids were the tallest standing object in the world for like 3,500 years. And they used to be topped with the plating, and the plating was painted, and some of it was gold plated, so you could see it for miles. And of course, the plating is worn off, and so is the painting, and most of the covering is worn off. So all you see are these big stones. And how do they move those stones? Does anybody figure that out? A lot of people think they've got it figured out. I don't think they've got it figured out because the way they describe it. Anyway, they spent years building it. That meant that death was really important. Anyway, here's an icy pyramid. You could draw this figure and label the dimensions. So if I've got some pyramid, and it doesn't matter what the base is, I could have any kind of base I want. I'll just draw a base like this. It says the height is going to be 15, so I'll do that in red. The height has got to be 15. And the pyramid itself has to have a volume of 720. So what does this area of the base have to be? for it to be a volume of 720. My volume is equal to 720. My volume is equal to 1/3 times the area of the base times the height. So the question is, how much is the area of the base? So 720 is equal to 1/3 times the area of the base times 15. And if you do the math, you end up with 144. It's got to be my area of my base. And that's really pretty cool when you look at the next slide. Oh, show your work. So the next slide here. We're going to find a base that satisfies this using this GeoGebra activity. This is really cool. Now, I hope you appreciate the work that went into preparing this lesson and coming up with this. This is pretty cool. I didn't actually do this, create this, but we're using it. Now, I'm going to use 144. I'm going to use a 12 by 12 base. So I'm going to put the Shift key, and that will allow me to make this even bigger, so I can go up to 12. And here I'm going to go this side all the way up to 12. And I'll start at 0, 0. I'm going to create my base, so I'll go at 0, 0. I'm going to go all the way over to 12. I'll go over to here to 12, and over here to 12. So this is going to give me an area of 144. And then I want to extrude this. I'm going to pull this up to an altitude of 15. And when I do that, I get this pyramid. This is like way cool. I can use this rotation. You can see this is a pyramid, and it's got this graphic. And I could change the base to be any shape I wanted to. I just chose to be a square for the interest of time and whatever else. But you can see that my volume, oh, well, let's check the volume. Here's a measuring tool. I can measure the volume of this guy. There it is, 720. No matter which way you look at it, which way you look at it, I'm going to look at it this way. I can see here, it's going to be 700. Wow, that's pretty cool. I got to say, that's pretty cool. You get to play with it, and you can show me your work and show me your picture of it. Lesson synthesis. Strategies for working with pyramid volumes. Write the formula, substitute values, and solve. How are the expressions 1/3 the area of the base times the height equal to 1/3 pi r squared times the height? Pi r squared would be the area of the base. That would be a circle. And how do you find the volume of an oblique cone? Well, you have to find the height of that is perpendicular to the base. Suppose you know the volume of a pyramid with a rectangular base of 200 cubic units. How could you find the set of dimensions for the pyramid? Well, you would have to work backward. If you knew the volume, you could work backward to find the height. You could work to find 200 cubic units. What type of shape would give you 200 units? And here's an excellent thing here. So you need to give me an example of a volume of 36 cubic units. What dimensions would give me a volume of 36 cubic units for a thing? And explain your reasons. Explain how you would get this. And that's all I've got for today. So good luck and success.